I was asked a couple of questions about what this setting here, client connector can receive CNAME, so CNAME flattening, and the effects that it has on web servers and authentication and things. So I built a bit of a lab, and I thought I'd run through it. So I've got a web server running. The web server is called Test Web. It's got Windows authentication enabled on the server. And if I run you through how that's configured, we've got a website called Test Web. Test Web resolves via a CNAME for testweb.loadbalance.com. Loadbalance.com is a DNS domain that exists here and returns an A record for the actual name of or the IP address of the server. And that's to kind of give an approximation for how things like AWS load balancing or passing things through an ADC will work. So if you do an NS lookup for testweb.welshgeek.net, testweb resolves to loadbalance.com, which resolves to 1.7. Nice and simple. And what I've got is a packet capture running on my domain controller on the web server, and the same on the domain controller here as well. So if I open the browser at HTTP test web, it opens up, and if I do a K-list, I tried to get a Kerberos ticket. I got a ticket granting ticket, but I didn't get a service ticket. And if I look on my domain controller, what happened was I got the ticket granting ticket, and then I requested an access ticket, a service ticket, for testweb.loadbalance.com, and I got a principal unknown. Okay. And that's kind of weird. I should have gone and asked for a ticket for testweb, but it didn't. It asked for testweb.loadbalance.com. And if I come across to the web server, what actually happened was it sent the 401 unauthorized with negotiating NTLM. We know the client then went and asked for a service ticket, which failed. So the client then said, well, I'm actually going to do NTLM authentication. And this isn't an unusual configuration, but what customers or users or administrators think is happening is Kerberos authentication. They're getting transparently signed in. And what's actually happening is it's doing NT challenge response. So the client sent a GET with a credential. Here's my challenge, and here's my response with my logged in user. NT challenge response. So that's kind of interesting. I didn't get the service ticket or whatever. Now people move to ZPA, or let's actually ignore ZPA for a second. I could come over to my server, my machine here. We'll do a K-list purge again, and this setting here, disable auth negotiate CNAME lookup. It's currently set to 0. That's the default, so you are not disabling it. If we change this to 1, we will disable the CNAME lookup. And what the effect of that will be, what I'll do is I'll come back over here where I will restart this capture. We don't want to say, no, wrong button. We'll restart the capture, continue without saving, and we'll restart this capture on the domain controller, continue without saving, and we'll close down the browser, reopen the browser and go to test web. that worked fine. And what will then have happened, should then have happened, no, I know what's happened. Hold on a second. This time made a request for testweb.welshgeek.net. I disabled the CNAME, and that principal is unknown. Okay. And so there really should be a service principal for this. This is the actual web server I want. So I'll go ahead and I'll create that. Oh, hang on. Set SPN-A HTTP testweb.welshgeek.net, and that is on certserve. Okay. So we'll restart the packet capture, continue without saving. We'll restart this packet capture, continue without saving. We'll close this down, klist purge. We'll open the browser again, test web. We'll come back across here. And at this point, I actually requested a ticket for test web. I got the ticket for test web. And here, 401 unauthorized, and now I send the GET request with the negotiate header. And so that all just works. Now, so what this is saying, what we've just done on the browser is said, don't do the lookup for the CNAME, because if you look up the CNAME, you'll get the load balancer, and then you'll request the ticket for the load balancer, and the ticket, there's never going to be a ticket issued for the load balancer. So there's a couple of odd things that go on necessarily with load balancers, things like that. We could also do a couple of other things. Okay, let's purge. Let's change this back. Disable auth negotiate CNAME lookup. We'll put that back to 0. Let's restart this packet capture. Continue without saving. And so let's delete that SPN. And what we will do is testweb.loadbalanced.com, which will register. And then we can have a look what went on there. Hold on a second, it didn't request the right ticket. Oh, we didn't clear the Kerberos tickets. If we look here, we actually had a klist purge. Klist. This time it went and got the ticket for testweb.loadbalance.com, because we can see that here, and here it said get, hold on, I should have restarted it, 401 is unauthorized, and now it sends the get request with that SPNEGO from the realm test web load balance.com. So the web server has accepted the ticket, even though the FQDN of the web server is testweb.wellsgeek.net. I've got a service ticket and it's going to accept it, and that's fine. So there's two different ways to solve that problem. I either tell the browser not to request tickets for the CNAME, or I have the service ticket for the real FQDN, or I have the service registered against the CNAME, as in what is going on with the load balancer, and I let the browser just go and request those as normal. So great, Mark, that's really interesting, but what does that have to do with ZPA? Well, let me show you. If we go ahead and let's launch Zscaler client. I don't know why it's taking quite so long to connect, but okay. Let's ping testweb.wellsgeek.net. I get the 164.1.1. NS lookup testweb.wellsgeek.net. It doesn't get the CNAME. Should have. Let's close the browser. Make sure we've got that. Test web. Oh, not HTTPS. Test web. And it went and got that page correctly. And so the client, in fact, what we'll need to do, stop this. .19 is the IP address of my app connector. I'll just restart this because we need to oh, I don't need to set a different filter on that. We can just click go on that and continue without saving. Okay, so we got our captures running, and we'll open this browser now. HTTP test web. Let's take a look here. First of all, it made the request for testweb.wellsgeek.net, and it got the principal unknown. And the reason it made the request for that was because it didn't get the CNAME. Okay. The CNAME is what was registered for the Kerberos ticket, testweb.loadbalance.com. So the client made a request for testweb.welshgeek.net. That's all it knew about, and that principal does not exist. And therefore, if we come across here and take a look at the headers, got the 401 unauthorized, he was unable to get the Kerberos ticket, so then he went ahead and did the NT challenge response. So we got signed in, but we were expecting Kerberos, and it did NT challenge response. Now, if the web server wasn't configured for NT challenge response, it was only Kerberos, then things would fail. So that's where it's really important that we're able to match the same configuration through ZPA as we are through when you're on network. I'm not entirely sure why the client connected didn't get the CNAME as I'd expect. Let's take a look at that. Okay. So what we'll do is we'll restart the capture. We'll restart this capture. and we'll come back over here. What we're going to do is we're going to delete that entry, and we'll add back in the testweb.welshgeek.net. And so back over at the client now, let's close this down. HTTP test web. At this point, it should have gone and got the Kerberos ticket. But it didn't. Oh. Because it caches the fact that it wasn't able to get one. Let's close that and redo it. Okay, so here's the request, here's the reply. It got the Kerberos ticket for test web because it was doing the CNAME flattening. And on the web server, we see the get, we see the 401 unauthorized, and we see the get with the Kerberos ticket in there. So the client's able to get the Kerberos ticket, that's all fine. The web server is able to decode it, that's all fine. The CNAME flattening is just working. Now, I'm going to restart this capture again. One issue that I did see with a customer the other day was the fact that on network they weren't able to get the Kerberos ticket because it didn't exist for the load balancer, and they were able to get the Kerberos ticket when they were on network, and yeah, the flattening actually created more problems. And the problem was that whilst the ticket existed for the flattened name, the web server wasn't able to decode it. So if I reproduce that problem, what I'll do is I will delete this SPN and I'll register the SPN for something entirely different. Let's call it Apache. I've got a server that's an Apache server, and what this means is that when the client goes and requests the ticket for this, it'll actually be issued by this for this service, which means that the web server itself, what's called CertServe, is not able to decode it. I'm kind of spoofing a bit of a Kerberos problem where the Kerberos ticket is not decodable by the web server. Okay. And so if we restart this, continue without saving, we'll come over here, klist purge, just make sure I've done it right, and we'll go to test web now. What has happened is, oh, hang on, test web, did I register it correctly? Oh, I did a D, I meant to have done an A, there we go. Add that, restart the capture, restart this capture. Klist purge, okay, and I get prompted, and the reason that I get prompted is because the ticket that I was going to get was, we see it here, I requested a ticket for test web. I got a ticket for test web. When I come over here, I get the 401 unauthorized. I present the ticket for test web, but the web server says this ticket is not available. Yeah, there's a problem with this ticket, and the client just fails and fails and fails, and that means that I get prompted for authentication. Now, let's cancel that. Let's klist purge. I'm going to come off of ZPA, exit, continue. So we're back on network, and here NS lookup test web resolves with the CNAME in there, as you'd expect. Let's close the window. Okay, let's purge. We will come across here, we'll restart this capture, continue without saving, and we'll restart this capture, continue without saving. Okay, so we're on network, no CNAME flattening, incorrectly registered Kerberos service principal name. Well, what's actually going to happen here is if we go to test web, the page displayed correctly. We see the client makes the request for the ticket, but because there's no CNAME flattening, the client requests a ticket for the CNAME. That fails, and so the client here, if we look at the packet capture, at this point he got the 401 unauthorized. He tried to go and get the Kerberos ticket in about this time frame. We didn't get the Kerberos ticket, so he then does NTLM, or NT challenge response, and they're logged in. So the root cause of the pop-up that we saw at ZPA was because we flattened the CNAME. The client was able to get a Kerberos ticket for that flattened CNAME, and the web server was unable to decode it. When on network, there was no CNAME flattening. The client was unable to get the ticket for the unflattened CNAME, and therefore they went to NT challenge response. So we have two solutions to the problem. We either reproduce, we don't want to have CNAME flattening through ZPA, or we actually fix the problem and we say we register an additional service principal name for test web. Let's delete the service principal name that was incorrect, and now we're going to add one for certserve, and we will add one for testweb.loadbalanced.com. Oops, wrong query. We have two service principal names registered for that server. basically saying the server can get tickets for both, or the server runs tickets for both. And with this scenario, let's restart our packet captures here, continue without saving. Let's restart this packet capture, continue without saving. Let's run the klist purge. Run Zscaler. Okay, so we're now on ZPA. We're able to access the web server. We requested a ticket for test web. We got the ticket for test web. And when we look here, 401 unauthorized, here's the get with the Kerberos ticket in it. So we actually solved the problem by making sure the web server is correctly registered with the correct service principal names. Even though CNAME flattening is happening, we could also do things without the CNAME flattening. So, hope this helps. Cheers, Mark.